All right. So now we're kind of jumping into where the real fun begins as far as intermediate one is concerned. We're going to be jumping in the time value of money. We're going to try to again kind of make each lecture about 15 minutes or so. Do my best to kind of break it down into pieces. And so with this first one, we're going to kind of jump into some concepts, maybe get some of the few basic TVM calculations and things like that out of the way. But hopefully this is helpful. So let's jump right into it. All right. So first things first, sorry about that. We needed to distinguish between simple and compound interest. And so when we're thinking about time value of money, the important thing is we're really talking about compound interest. And a lot of times to date, unless you're taking a finance class, maybe, you've really only discussed simple interest. And so let's kind of make a distinction between those two. And so, so what is the difference? So first of all, simple interest is where interest is charged only on the principal amount, whereas compound interest is it's charged on the principal and any accrued interest. So the key feature, the key difference really is that interest on the interest in addition to interest on the principal. And so I think, illustrating that's probably the easiest way to do it. And so we're going to kind of walk through how much would compound or how much would be in an account if it was simple interest or versus compound interest. So again, or not how much but how much you would owe. And so with the simple interest bearing note, after 1 year, you owe the $10,000 that you borrowed plus 10% interest or 11,000. After two, of course, you have another $1,000 of interest because the interest is on the principal only. So you'd owe $12,000 after the second year and then 13,000 after the third year. And again, this is probably something that you've seen before. Where it's a little bit different though is with compound interest. So same thing after the first year, it's the interest on the principal because there's really no accrued interest at this point in time. Where it starts to change though is in the second year. And so you can see that after year two, not only do you owe the 11,000 from the first year, but now you have interest. But notice how the interest, instead of being on $10,000, the interest is going to now accrue on $11,000, right? So you see that difference of 10,000 versus 11,000. And so that extra interest on interest is really where we get the extra $100. So you can see that instead of 12,000, we owe 12,100 after the second year using compound interest. Now, as far as the third year, again, similar idea, but again, we have the original amount that's owed. So up here, of course, we're building off 12,000, whereas down here, we're building off 12,100. That's already one difference. And then the second difference is that, again, with simple interest, the interest is only on the $10,000, whereas with compound interest, it's owed on the entire $12,100. And so now, of course, at the end of the day, we have 13,310 instead of just 13,000 from up above. So again, the interest on the interest is what accounts for the $310 difference between the two. And that's really how compound interest works. It's really all about the interest on the interest, and that accelerates the way that the time value of money, the way the money grows, whether you owe it or whether it's owed to you, it changes the way that it grows. So that just kind of does kind of get us to this idea of an effective interest rate. And so, most rates, when you see them in this class or any other setting, you're going to see an annual percentage rate. And what you're going to start to see is that as interest is compounded more frequently, that's going to actually change the effective rate. And so as you can see, but the fact that interest was accruing annually meant that, okay, after 1 year, you owe principal plus interest. And then the next year, that amount of accrued interest mattered. Well, imagine instead of going, 1 year, 2 years, 3 years, imagine that within a year, we started compounding interest more frequently than just annually. What if we did it quarterly or monthly or semi-annually, whatever it might be? All of a sudden now you start accruing interest earlier on, and now that interest on interest starts to accelerate. But the key difference though is that we're not talking about, the key is we're holding in this, I guess, concept, we're holding the APR constant. And so we want to know what happens when you have an APR that is, but where the interest is compounded more frequently. Well, it's going to change the effective rate. In fact, the more frequently you compound interest, the higher that effective rate is going to be. And so let's kind of talk about that. All right, so let's kind of sorry, again, that's the summary. So the more frequently it's compounded, the higher that effective rate is going to be. All right, so let's extend our example above. As you recall, when interest is charged annually, the company owed $11,000, didn't matter, compound or simple interest. You owed $11,000 after 1 year. What if instead we compounded interest semi-annually? Then what would our effective interest rate be? Would it still be 10%, or would it be more or less than 10%? And I think we already hinted that it's going to be more. Well, let's kind of see exactly what we're talking about. So let's say that we're semi-annual interest. The key, though, is now the periodic interest rate. So the annual interest rate is 10%. The periodic rate then would be half that, or 5%. After the first semi-annual period, you would owe $10,000, which is the principal, plus any interest on the principal. But again, the rate that we're going to use is that 5%. So after one semi-annual period, we would actually owe $10,500. After the second semi-annual period, not only would we owe the $10,500, but now we owe another 6 months interest on the $10,500 that we previously accrued. And so now the total amount that we would owe after 1 year, instead of $11,000, notice that it's $11,025. Again, because we are compounding interest more frequently, the account what we're going to owe is going to grow more. And so then the effective rate is 10.25%, not just 10%. And again, that is the effect of increasing the frequency by which we compound interest. All right, so there's another spot here where I want you to pause the video if you're watching this, and do this next problem on your own. So the question really is, what if instead of annually or even semi-annually, we started to accrue quarterly? So my first question is, do you think it's going to be more than 10% and even more than 10.25%, which is what our semi-annual rate was, effective rate? And so, first of all, answer that question. And then secondly, actually do the calculation. See if you can actually calculate the effective interest rate. Again, pause here, do this on your own, and then pick it up after you've completed whatever you could. Okay, so hopefully you did that. So again, looking at quarterly interest, again, our APR, rather than be divided by 2, you need to divide by 4, again, because now we are compounding 4 times per year. And so then after 1 quarter, again, you owe the $10,000 plus 2.5% of 10,000, which is $10,250. After a second quarter, again, not only do we have the amount we owe after 1 quarter, but now we have interest on that amount for a total of $10,506. Then after 3 quarters, $10,769. And then finally, after the 4th quarter, if I could have done that correctly, instead of second quarterly period, that should say 4th. And that should say 3rd. Sorry for the typos. We'll just kind of finish the thought there. That should be 3rd and 4th. Anyway, so you can see that in total we owe $11,038. And so that means our effective rate is actually 10.38%. Again, it went from 10% to 10.25% to 10.38% because we are compounding interest more frequently. And of course, if we did it monthly, it would even go up from there. If we went it daily, it would even go up from there. And again, this is the power of compound interest. And so this is one reason why, for example, credit cards, they will compound interest daily on any amounts that are overdue. And so you might have an APR of 12% or 15% or whatever they are nowadays, but understand the daily rate is that annual rate, and then it starts compounding. So it's interest on a daily basis. And so you can see your effective rate really is more than whatever your stated APR is. Okay, a little more. So just sort of let's take what we learned and try to generalize it. So again, there can be a general form where we can start to understand how to calculate and interpret effective rates. So on a test, you are going to be responsible for knowing some of the equations that I highlight. I will let you know situations where I might show you an equation, but not really require that you know it. In this case, you need to know and understand how to calculate an effective rate. And so you can see, you take whatever your annual percentage rate is, and you divide it by the number of times you're going to compound within any given year. So as an example, quarterly, the n would be 4, semi-annually, the n would be 2, monthly, the n would be 12. And you can see that the frequency that we're compounding shows up two places. Not only do we divide the APR by that frequency, but then we take it to the power after adding 1. And this is where we get that effective rate. So 1 plus the APR divided by n to the nth power minus 1. So this is the general form equation for calculating an effective interest rate. Okay, now I'm going to kind of stop there. That was actually a pretty brief one, maybe 10 minutes, but I'm going to stop there. We're going to pick up the next one. We're going to do a future value of a single amount and and see how long that takes us. We're going to try to break this up into somewhat manageable pieces. And so we're going to stop recording here and we will pick it up next time.